Alright, so for number 39, you have a hockey player is standing on his skates on a frozen pond when an opposing player, moving with a uniform speed of 12 meters per second, skates by with the puck. After 3 seconds, the first player makes up his mind to chase his opponent if he accelerates uniformly at 4.0 meters per second squared. A, how long does it take him to catch his opponent? So for A, you would have to use a system of equations. So using your information for player number 1, who is the person chasing the opponent, he starts at 0 meters per second because he's at rest, so that's his initial velocity. If you use this kinematic, then you plug in 0 meters per second for his initial velocity. And then for his acceleration, you would plug in 4 meters per second because he's accelerating uniformly at 4 meters per second squared. So then you would plug that into here, and then you're solving for the time. How long does it take him to catch his opponent? So then for his opponent, you would use the same kinematic equation, and then because it says that the opposing player is moving with a uniform speed of 12 meters per second, that would be his initial velocity because it doesn't say anything about a different velocity before that. So then that would be your initial velocity, and then his acceleration would be 0 because it says he's moving uniformly, so he has no change in velocity. And then you know that because 3 seconds has passed and the first player has been moving for 12 meters per second for 3 seconds, you can simply multiply 12 times 3 and then get 36 meters. So then you would know that the distance between the first player and the second player would be the second player's distance plus 36 meters. So then you would simply plug in these values into this equation, which would give you, if you multiply 4 meters per second times a half, that would give you 2 meters per second squared times t squared. And then you would have to plug in delta x2 because 1/2 times 0 times t squared, that cancels for 0. You would just have 12 meters per second squared, 12 meters per second times t, and then plug that in for delta x2 plus 36 meters, just that part right there. And then when you multiply everything out, you would get a quadratic, so then you would have to use the quadratic formula. And then when you solve that, you would get 8.2 seconds or negative 2.2 seconds, and you can't have negative time, so your answer would be 8.2. And then for B, how far has he traveled in that time? Assume that the player with the puck remains in motion at constant speed. So now that you have time, you can use the original information given. So again, 0 meters per second because he was at rest in the beginning, and then 8.2 seconds, which we found here, and then you have acceleration is 4 meters per second as given in the problem. So you would use this kinematic, delta x equals initial velocity times time plus 1/2 acceleration times time squared. So then initial velocity is 0 times time plus 1/2, plug in acceleration, plug in time, and then when you solve, you get delta x equals 130 meters. That's it.